All right, in our lesson today, we're going to take a look at adding and subtracting radical expressions. And I want you to keep these three rules in mind anytime you are asked to add radicals or subtract radicals. So the first rule says that you can only add or subtract radical expressions if the radicands are the same. Remember, the radicand is that number or that expression that's underneath or inside the radical. So for example, square root of 3 plus square root of 3, we could add those together. I mean, it doesn't become square root of 6, but we're allowed to add those two square roots together because they contain the exact same radicand. The non-example shows the square root of 2 and the square root of 3 being added together, where we can't actually add those because square root of 2 is different than the square root of 3. So rule number 2 is kind of going to explain a little bit more how that works. We kind of treat these radicals like variables. And anytime that we're adding terms with variables, we can only add or subtract the terms if they are like terms. So in this case, these radicals are kind of like terms if they're the same. So square root of 3 plus square root of 3, those are like terms. But the square root of 2 and the square root of 3 are not like terms, so we can't add anything together. So with rule number 2, that explains how we add those together. Just like with variables, we add the coefficients, but we leave the variable part the same. With radicals, we still add the coefficients, but we leave the variable part the same in our answer. All we're doing is adding together. In the example here, 3 plus 7 is 10. So 3 square root of 5 plus 7 square root of 5 is equal to 10 square root of 5. And rule number 3, we just make sure that we always simplify our answer. If when we add two radicals together, we get something that can still be simplified, we go ahead and simplify it. So here are some examples to help understand how we add and subtract radicals. In example A, it reads that we are taking 3 square root of 7 plus 8 square root of 7. We recognize that we're adding square root of 7s with other square root of 7s, so this is okay. It is legal to do this. They are considered like terms. And all we do is add the coefficients. If I have 3 of something and I add 8 more of the same thing, I'm now going to have 11 of those things. So it's 11 square root of 7. In example B, the first thing we want to check and see if it's actually allowed to do anything with combining like terms. And yes, they both contain the square root of y, so they're like terms. For the subtraction, it's 9 square root of y, subtract 1 square root of y, which becomes 8 square root of y. In example C, in this case, I see that I have square root of 2's and I have square root of 11's. Now those are different things. They're not like terms anymore. So I can't actually subtract anything. It's like saying I have 5 apples and I'm going to take away 3 oranges. You can't do that. You can't take away oranges from apples. It just doesn't work. In example D, this time we have 3 terms and we have numbers and variables included. Like radicals are the ones that have the exact same radical part, the radicand. So I have square root of 3d in the first term. I have square root of 2d in the second term, so those aren't like terms. But then I have another square root of 3d in the last term. So I have the first term and the last term are like terms. I can combine those like terms by adding their coefficients. Negative 8 plus 10 is positive 2. So I have 2 for the square root of 3d plus the 6 square root of 2d. Let's look at a few more examples together. In example 1, I have square root of 12 plus 3 square root of 3. At first glance, it looks like square root of 12 and square root of 3 are different things, which they are. I'm not able to add those the way that they are right now. However, we can simplify the square root of 12. 12 is the result of 4 times 3. So this would be the same thing as the square root of 4 times the square root of 3. And I know that the square root of 4 is 2. So now I have 2 square root of 3 plus 3 square root of 3. And in this case, I have the exact same radical, so I can add these together. Since 2 of something plus 3 of something gives me 5 of them, this is going to be 5 square roots of 3. Notice I don't add the 3's together. It doesn't become square root of 6. I leave that radicand the same. I'm just adding up how many of those square roots I have. In example 2, I see that square root of 18 is different than square roots of 2. However, the square root of 18 can be simplified. I know that 18 is the result of 9 times 2. So if I think about simplifying that radical, I have, well, the 3 that was already out front, and then the square root of 9 times the square root of 2 when I break up the square root of 18. Let's see, what can I do with that? The square root of 9 is exactly 3. So 3 times another 3 times the square root of 2. And 3 times 3 is 9, leaving me with 9 square root of 2, subtract 2 square root of 2. Now I have some radicals that are the exact same radicands, so I can go ahead and combine these. If I have 9 of something and I take away 2 of them, I'm left with 7 of those things. So it's 7 square root 2. For number 3, let's see, we have square roots of 27 and square roots of 12. Well, those are different radicals, so I can't subtract them the way they are right now. I have to try to get them the same. Well, let's see. Can we simplify the square root of 27? And I believe we can if we treat it as, well, 9 times 3 is 27. And since 9 is the perfect square, I actually want to write that first. All right, so let's see. The square root of 9 is 3. Let me just change that. And when I multiply it together with that other coefficient of 3, this is going to change it to 9 square root 3. All right. Now the other radical, 2 square root of 12, well, let's see here. 2, and the square root of 12 is 2 times 6. That's not going to help me. How about 4 times 3? That'll work because the square root of 4 is exactly 2. So I'm going to change this to a 2, keeping my multiplications. And now I can combine those non-radicals. 2 times 2 times the square root of 3 is 4 square root of 3. All right, now I have 2 radical expressions that have the exact same radical part. So I can combine these. It becomes, let's see, 9 square root of 3 minus 4 square root of 3 is going to be 5 square root of 3, because 9 minus 4 is 5. Keep the radicand the same. In our last example, we have 3 square root of 2, and then minus 4 square root of 50. Those are different radicals. And then 162 and the last radicand, that's not going to be the same either. So right now I can't combine anything the way it is. So let's see if each part can be simplified. Well, 3 times the square root of 2 can't be simplified because the square root of 2 is as simplified as it gets. For the next part, 4 times the square root of 50. Let's see, I've got the 4, and then what multiplies up to 50? 5 times 10, but 5's not a perfect square, 10's not a perfect square. 25 times 2. And that's helpful because the square root of 25 is exactly 5. So 4 times 5 times the square root of 2 for that middle term. And that's going to become 20 square root of 2. We still have one more part. Okay, the square root of 162. Oh boy, that's a pretty big number. Better use my chart on that one. Let's see if I can find 162 in one of my lists. There it is. It's 81 times 2. 81 times 2. So square root 81 times the square root of 2 is that square root of 162. Should have kind of grouped those together so you could see where it all came from. And the square root of 81, of course, is 9, since 9 times 9 equals 81. So that last expression, square root of 162, is the same as 9 square root of 2. Now here I notice that I have square roots of 2, square roots of 2, and square roots of 2. I have 3 radicals that are all considered to be like terms. So all I have to do is take these coefficients, 3 minus 20 plus 9, and I'll have my coefficient of the answer. I'm going to leave the square root of 2 the same. I just want to figure out what number goes in front of it. So 3 minus 20, that's negative 17. And then negative 17 plus 9 is negative 8. So it becomes negative 8 times the square root of 2.